It is not legal to use 4/0 Superflex welding cable rated at 600 volts in place of 4/0 THHN. Firstly, THHN is a type of insulated wire specifically designed for use in indoor electrical systems, while Superflex welding cable is a type of uninsulated flexible cable intended for use in welding applications. Secondly, THHN is rated for 600 volts, while Superflex welding cable is also rated for 600 volts. However, the insulation properties of THHN are more suitable for use in electrical systems where insulation is required. Thirdly, the National Electrical Code (NEC) does not explicitly prohibit the use of Superflex welding cable in place of THHN. However, it does require that the conductor type used meets the specific requirements for the intended application. Fourthly, using Superflex welding cable in place of THHN can pose a safety hazard because the uninsulated nature of the welding cable increases the risk of electrical shock and short circuits. Fifthly, using Superflex welding cable in place of THHN would be a violation of the NEC code, which could lead to fines or penalties. It is not advisable to use Superflex welding cable in place of THHN. Instead, it is recommended to obtain the correct type of conductor 4/0 THHN for the intended electrical installation. The selection and application of conductors in electrical systems are governed by the National Electrical Code (NEC). This code provides comprehensive guidelines to ensure safety and proper functionality. Understanding the different types of conductors and their appropriate uses is crucial for any electrical work. Let's delve into the specifics of THHN wire and welding cables, and why they are not interchangeable in typical electrical installations. THHN, which stands for thermoplastic high heat resistant nylon coated, is a common type of building wire used in residential, commercial, and industrial applications. Its construction consists of several key components. The conductor is typically made of copper or aluminum, providing the pathway for electrical current. Copper is preferred for its high conductivity and lower resistance, but aluminum is sometimes used for larger gauge wires to reduce weight and cost. The insulation layer is made of a thermoplastic material, usually polyvinyl chloride, PVC, which provides electrical insulation and protects the conductor from environmental factors. The nylon jacket provides additional protection against abrasion, moisture, and chemicals, enhancing the wire's durability and lifespan. THHN wire is designed for installation in conduit or other raceways, offering physical protection and allowing for easy replacement or upgrades. It is rated for a maximum operating temperature of 90 degrees Celsius or 194 degrees Fahrenheit in dry locations, and 75 degrees Celsius or 167 degrees Fahrenheit in wet locations, making it suitable for a wide range of environments. The voltage rating for THHN wire is typically 600 volts, which is standard for most general-purpose electrical wiring. Common applications of THHN wire include branch circuits for lighting and receptacles, feeder circuits for distributing power to subpoles, and control wiring for machinery and equipment. Its versatility and robust construction make it a staple in electrical installations. Welding cables, on the other hand, are specifically designed for welding applications where flexibility and high current carrying capacity are essential. Welding cables have distinct characteristics that differentiate them from THHN wire. The conductor is made of finely stranded copper wire, providing maximum flexibility and allowing the cable to bend and flex without damage. The insulation is typically made of a synthetic rubber compound such as ethylene propylene diene monomer (ETDM) or neoprene, which offers excellent flexibility, heat resistance, and resistance to chemicals and abrasion. Welding cables are designed to withstand the harsh conditions of welding environments, including exposure to heat, sparks, and weld spatter. While welding cables are rated for 600 volts, similar to THHN wire, their primary focus is on flexibility and current carrying capacity rather than insulation for general-purpose wiring. Common applications of welding cables include connecting welding machines to the workpiece, providing power to electrode holders, and grounding welding equipment. Their flexible construction and high current capacity make them ideal for these demanding applications. The National Electrical Code NEC is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and maintained by the National Fire Protection Association (NFPA) and is widely adopted by state and local jurisdictions. The NEC aims to ensure the safety of people and property by providing requirements for the design, installation, and inspection of electrical systems. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect advancements in technology and address emerging safety concerns. Compliance with the NEC is essential for all electrical work to ensure safety and avoid potential hazards. Several NEC articles are relevant to the discussion of THHN wire and welding cables. Article 310 covers conductors for general wiring, including THHN wire. It specifies requirements for conductor insulation opacity and installation methods. Article 400 covers flexible cords and cables, which may include welding cables in certain applications. It outlines the requirements for the construction, opacity, and use of flexible cords and cables. Article 630 covers electric welders and associated equipment. It provides specific requirements for the wiring and grounding of welding machines to ensure safe operation. While the NEC does not explicitly prohibit the use of welding cables in place of THHN wire in all situations, it does emphasize the importance of using conductors that are suitable for the intended application. The NEC requires that conductors be properly insulated, protected, and installed in accordance with their listing and labeling. Using welding cables in place of THHN wire may violate these requirements if the cables are not designed or listed for general-purpose wiring. Fundamental differences between THHN wire and welding cables make them unsuitable for interchange in most electrical installations. Firstly, insulation is a critical factor. THHN wire is designed with a thermoplastic insulation layer and a nylon jacket, providing excellent electrical insulation and protection against environmental factors. Welding cables, on the other hand, typically have a synthetic rubber insulation that prioritizes flexibility and heat resistance over insulation for general-purpose wiring. Using welding cables in place of THHN wire could compromise the insulation of the electrical system, increasing the risk of electrical shock and short circuits. Secondly, the application is key. THHN wire is intended for use in permanent wiring installations such as branch circuits and feeder circuits. It is designed to be installed in conduit or other raceways for physical protection and to meet the requirements of the NEC. Welding cables are designed for temporary connections and are not intended for permanent wiring installations. Using welding cables in place of THHN wire could violate the NEC requirements for wiring methods and could lead to safety hazards. Thirdly, flexibility matters. THHN wire is a solid or stranded conductor that is designed to be relatively rigid and maintain its shape when installed. Welding cables are made of finely stranded copper wire, providing maximum flexibility for welding applications. Using welding cables in place of THHN wire could make it difficult to install and terminate the wiring properly, increasing the risk of loose connections and electrical faults. There are potential safety hazards associated with using welding cables in place of THHN wire in general-purpose electrical installations. Increased risk of electrical shock due to the different insulation properties of welding cables. There is a higher risk of electrical shock if the insulation is damaged or compromised. Increased risk of short circuits. The uninsulated nature of welding cables could increase the risk of short circuits if the conductors come into contact with each other or with grounded metal surfaces. Overheating of conductors. If welding cables are not properly sized for the intended load, they could overheat and potentially cause a fire. Non-compliance with the NEC. Using welding cables in place of THHN wire could violate the NEC requirements for wiring methods, conductor insulation, and overcurrent protection, leading to fines and penalties. It is important to select the correct type of conductor for the intended electrical installation to ensure safety and compliance with the NEC. Using the wrong type of conductor can create potential hazards and compromise the integrity of the electrical system. In summary, THHN wire is designed for general-purpose wiring and provides excellent insulation and protection. Welding cables are designed for welding applications and prioritize flexibility and current carrying capacity. The NEC requires that conductors be suitable for the intended application and installed in accordance with their listing and labeling. Using welding cables in place of THHN wire could violate the NEC requirements and create potential safety hazards. Always consult with a qualified electrician or electrical inspector to ensure that the correct type of conductor is selected for the intended electrical installation. To reinforce the importance of using the correct conductor type, let's consider a few specific scenarios where using welding cables in place of THHN wire would be problematic. In residential wiring, THHN wire is commonly used for branch circuits that supply power to lighting fixtures, receptacles, and appliances. Using welding cables in these circuits would not be appropriate because they are not designed for permanent wiring installations and do not provide the necessary insulation and protection. In commercial buildings, THHN wire is often used for feeder circuits that distribute power to subpanels and equipment. Using welding cables in these circuits would be a code violation and could create a safety hazard due to the increased risk of electrical shock and short circuits. In industrial settings, THHN wire is used for control wiring and power wiring for machinery and equipment. Using welding cables in these applications could compromise the insulation of the wiring system and lead to equipment failure or electrical accidents. The NEC provides specific requirements for the ampacity of conductors, which is the maximum amount of current that a conductor can carry safely without overheating. The ampacity of a conductor depends on its size, insulation type, and installation conditions. THHN wire and welding cables have different ampacity ratings due to their different construction and insulation properties. Using welding cables in place of THHN wire could result in undersized conductors, which could overheat and potentially cause a fire. The NEC also requires that conductors be protected against overcurrent using circuit breakers or fuses. The size of the overcurrent protection device must be matched to the ampacity of the conductor to prevent overheating and damage to the wiring system. Using welding cables in place of THHN wire could result in improper overcurrent protection, which could increase the risk of electrical fires. Grounding is an essential safety measure in electrical systems. It provides a low resistance path for fault current to flow back to the source, allowing the overcurrent protection device to trip and de-energize the circuit. The NEC requires that all electrical equipment be properly grounded to minimize the risk of electrical shock. Using welding cables in place of THHN wire could compromise the grounding system, increasing the risk of electrical shock if a fault occurs. The NEC specifies requirements for the installation of conductors in conduit or other raceways. Conduit provides physical protection for the conductors and helps to prevent damage from abrasion, moisture, and chemicals. THHN wire is designed to be installed in conduit, while welding cables are typically used for temporary connections and are not designed for conduit installation. Using welding cables in place of THHN wire could violate the NEC requirements for wiring methods and could lead to physical damage to the conductors. Proper termination of conductors is crucial for ensuring a reliable electrical connection. The NEC specifies requirements for the types of connectors and terminals that must be used for different types of conductors. THHN wire and welding cables require different types of connectors and terminals due to their different construction and insulation properties. Using the wrong type of connector or terminal could result in a loose connection, which could overheat and potentially cause a fire. To ensure the safety and reliability of electrical installations, it is essential to follow the NEC guidelines and use the correct type of conductor for the intended application. When in doubt, consult with a qualified electrician or electrical inspector to obtain expert advice and ensure compliance with the code. Continuing with our exploration of conductor selection and safety, let's consider some real-world examples where the improper use of welding cables in place of THHN wire could lead to serious consequences. Imagine a scenario where a homeowner decides to replace a damaged section of THHN wire in a wall receptacle circuit with a piece of welding cable they had on hand. Because welding cable is not designed for permanent wiring installations and does not provide the same level of insulation as THHN wire, this could create a hidden hazard within the wall. Over time, the welding cable's insulation could degrade due to heat, moisture, or physical stress, leading to a short circuit or ground fault. This could result in a fire, electrical shock, or damage to the home's electrical system. In a commercial setting, consider a situation where a maintenance worker uses welding cable to extend a branch circuit for a new lighting fixture. The welding cable may not be properly sized for the load or protected by an appropriately sized overcurrent protection device. This could cause the cable to overheat, potentially melting the insulation and igniting nearby combustible materials. Such a scenario could lead to a significant fire, causing extensive damage to the building and endangering the occupants. In an industrial plant, imagine that a technician uses welding cable to replace a section of control wiring for a critical piece of machinery. The welding cable may not be resistant to the chemicals or oils present in the industrial environment. Over time, the insulation could break down, causing the control circuit to malfunction. This could lead to unexpected machine shutdowns, production delays, and potential safety hazards for workers. These examples highlight the potential dangers of using welding cables in place of THHN wire in general-purpose electrical installations. The NEC is designed to prevent such scenarios by providing specific requirements for conductor selection, installation, and protection. By following the NEC guidelines and using the correct type of conductor for the intended application, we can minimize the risk of electrical accidents and ensure the safety of people and property. To further clarify the differences between THHN wire and welding cables, let's examine their construction in more detail. THHN wire typically consists of a solid or stranded copper conductor, which provides a path for electrical current. The conductor is insulated with a layer of thermoplastic material such as polyvinyl chloride, PVC, which provides electrical insulation and protects the conductor from environmental factors. The insulation is covered with a nylon jacket, which provides additional protection against abrasion, moisture, and chemicals. Welding cables, on the other hand, typically consist of a finely stranded copper conductor, which provides maximum flexibility. The conductor is insulated with a layer of synthetic rubber, such as ethylene propylene diene monomer, ETM, or neoprene, which offers excellent flexibility, heat resistance, and resistance to chemicals and abrasion. The synthetic rubber insulation is often thicker than the thermoplastic insulation used in THHN wire, but it may not provide the same level of electrical insulation. The finely stranded construction of welding cables makes them highly flexible, allowing them to bend and flex without damage. However, this flexibility also means that welding cables are not as rigid as THHN wire and may not be suitable for permanent wiring installations. The different materials and construction techniques used in THHN wire and welding cables result in significant differences in their electrical and mechanical properties. THHN wire is designed to provide excellent electrical insulation and protection, while welding cables are designed to provide maximum flexibility and current carrying capacity. These differences make them suitable for different applications and prevent them from being used interchangeably in most electrical installations. In addition to the differences in construction and properties, THHN wire and welding cables also have different markings and ratings. THHN wire is typically marked with its conductor size, insulation type, voltage rating, and other relevant information. Welding cables are typically marked with the conductor size, insulation type, and ampacity rating. These markings provide important information about the conductor's capabilities and limitations and help to ensure that it is used safely and correctly. The NEC requires that all electrical equipment be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories ALL. This listing and labeling provide assurance that the equipment has been tested and meets the applicable safety standards. THHN wire and welding cables that are listed by UL or another recognized testing laboratory will bear the appropriate markings and labels indicating that they have been evaluated for safety and performance. It is important to look for these markings and labels when selecting conductors for electrical installations to ensure that they meet the required safety standards. In conclusion, the improper use of welding cables in place of THHN wire can lead to serious safety hazards and code violations. By understanding the differences between these two types of conductors and following the NEC guidelines, we can ensure the safety and reliability of electrical installations. Always consult with a qualified electrician or electrical inspector when in doubt, and never compromise on safety when working with electricity.